We're at gotomath.com, working some calculus, and I believe we're down here at inverse functions. And of course, this is going to be an introduction, so we're going to be clicking on that button. It says visit the video button for an introduction, and that's what we're going to talk about. We're going to talk about the inverse function, or evaluating the derivative of the inverse function. I believe that's what we're talking about. Let's go to the whiteboard. And I'm going to start by drawing a picture. So this picture here, I'm going to attempt to draw a picture. Oh my gosh, this is, okay, that's supposed to be the y-axis. And that is the x-axis. Now let's draw, alright, I'm going to draw a part of, we'll do this. Okay, this right here is going to be f of x. That's going to be f of x. And then we're going to draw the inverse. We're going to draw the inverse. And how about we use green? Okay, so I'm going to attempt to draw the inverse of this guy. So this is some particular function. This is not all right, this is some particular one. And this dotted line right here, this is a line. Okay. Alright. And of course we're just looking at this quadrant here, this line. This would go on like that. Now the dotted line is y is equal to x if we had to graph that. Okay, that's just y is equal to x. And of course this is f inverse of x, f inverse of x. So there's a picture that we're going to start with. Now, some things about the inverse function. Things that we need to know, how they're related. If we took a point, like let's pick a point right here, and we're going to call this a. Okay, we'll just call this number some number. We'll call it some number a there. All right. Okay, and then we'll call this associated with a over here, the y value, we'll call the y value b. We'll call the y value. Now this is the inverse function. Now this is the way this works. The inverse, if you plug a into the inverse of f, then we get, obviously, we get b out. Okay, we get b out. And if we plug b into the function, guess what we get out? Well, if they're inverses of each other, we should get a out. So if we plugged b into the function, so I'm going to attempt, I'm going to say b is right here. Right, so we take this number, then we measure over. Okay, and I'm going to say this is b. And if we take b and plug it into the function, we'll say it's right here. Then I made these guys kind of close together. That's supposed to be an a. We get a out. Okay, you see that? That's how this works. All right, get b out. I can see right now that this thing is definitely not to scale. That's not good. Anyway, as long as we know this right here, okay, plug b in, you get a out. Plug a into the inverse, you get b out. Okay, so my picture is not exactly accurate. I will just say that much right now. we're going to say, let's scratch this out right here. And we're going to say this is A right here. How's that? And we're going to say B's associated. It's kind of cockeyed here. B's associated with this point right here, okay? Make a little adjustment there. Now, what we're wanting to find is we're wanting to find we take the derivative of the inverse, which we're not given. Okay, so here's the inverse function right here. And this is actually the goal right here. Is we want to be able to plug in this A into the inverse and find the basically technically we're going to say that this is the we're going to say this is a tangent line right here at this point, but we want to find the slope of the tangent line because that's what the derivative gives us, the slope of this the slope of the tangent line. But the unfortunate thing is we're not given this. We're not going to be given this. We're going to be given this guy right here. This is the only thing we're going to be given. And so we're going to be able to take the derivative of f. We're going to be able to find f prime of x. Okay, and then we're going to be able to plug a number into it and find the actual, what's actually going to end up being the derivative. And I could probably be drawing a whole lot better picture here, but the slope of this tangent line, the slope of this tangent line. So this is going to be something that we're going to be able to do. We're going to be able to find the slope of this tangent line, and we're not going to be given this, but we're going to be asked to find this. Now, the relationship between this tangent line and the slope of this tangent line is simple. We're going to say that the slope of this tangent line is m. We're going to say the slope of this tangent line is m. Well, the slope of this tangent line, as long as these two are inverses of each other, the slope of this tangent line is the reciprocal of the slope of this tangent line. In other words, it's going to be 1 over m. 1 over m. Okay? So all we have to do really is find m. And when we find m, we can just say, well, we know what the slope of this tangent line is, and it's 1 over m. Because that's what this is going to be equal to, is 1 over m. Okay? So that's basically it in a nutshell. I mean, we're going to be given f of x. We're going to be given the a number a here, okay? And we're going to be asked to find this. So what we're going to have to do is this is the key right here. We're going to have to figure out what b is. Okay? We're going to be given a, and we got to find b. And once we find b, then we can take b and plug it into the derivative. So let me just rewrite this over here. So this is f prime of b, and f prime of b is m. F prime of b is actually m. And then once we know this, then we'll know what this is right here. It's 1 over m, you see. So all we need to do is find the slope of this tangent line. But we're given a, and we're given this up here. Okay? So this is easy. You just take the derivative of this, right? And then we're going to plug b into it, get m, and then we just put 1 over m, and we're done. But the trick is to be figuring out what b is. Okay, we got to figure out what b is, which means that what we're going to do is we're going to plug b into the function and set it equal to a, and then solve for b. All right. So this is general, but here, big picture is we need to find the slope of this tangent line. We're given f, and then we need to figure out what b is. We got to figure out what b is, but that's easy. We're going to plug b into the function, set it equal to a that they give us, and then solve for b. Right? That is all we're doing. on this. That's all there is to it. Okay, nothing more. And what you'll need to do is start with problem number 2 and with that example. So this is the more general picture right here. So you might be saying, huh, what are we talking about? But all you got to do is check out some examples and you'll get it. Now, we waved our hands and said that if these two are inverse functions and that the slope of this tangent line is the reciprocal, and that's something that can be easily proved, but we're not doing that here in this calculus class. Okay, anyway, that can be easily proved. Anyway, okay, well, I will see you somewhere. Let's go back. I will see you here at this problem right here where we're given A. Okay, remember we're given A. We're given f of x. So what we're going to do is we're going to take b, plug it in. So we're going to have 3b squared. We're going to set that equal to 300 and then figure out what b needs to be for that to be equal to 300. Then we just take the derivative of this guy and plug that b into it, and then it's 1 over b, and that's what this is going to be equal to. It's not that bad, I promise. Okay? Alright, and I shall see you here. Maybe.